our discussion about CAM pathway will not be complete unless we discuss about the regulation of CAM pathway. There are two types of regulation in CAM pathway. One is a long-term regulation, other one is a short-term regulation. Short-term regulation is generally from day-to-day basis. How is the short-term regulation carried out? We know that the most crucial enzyme in the CAM pathway is PEP carboxylase. So PEP carboxylase is an enzyme that is used for fixing carbon dioxide to phosphoenol pyruvate so that it becomes oxaloacetic acid, subsequently malate. In the malate which is formed, it is being transferred to the vacuoles and it is stored as malic acid. So malic acid is here. Now what happens? If all the malic acid is transferred to vacuoles, in the cytoplasm, the concentration of malic acid will be less. Malic acid is an inhibitor of PEP carboxylase. So malic acid is here. It can inhibit the PEP carboxylase. So therefore, by trapping it in the vacuole, what's the plant doing? It is minimizing the concentration of malic acid in the cytoplasm. So therefore, PEP carboxylase will be active in order to carry out fixation of carbon when it is less temperature, when at darkness. Now during daytime what happens? During daytime we need to switch it off. So there is an additional mechanism that it employs. What it employs is, over a period of time, the malic acid concentration will increase in the vacuoles. As the concentration of malic acid increases, it increases the turgor pressure. How? This is an osmotically active substance which will facilitate uptake of water. That increases the turgor pressure, and the turgor pressure reaches in such a state where the vacuole is not able to concentrate any longer malic acid. That is the time malic acid there is an efflux of malic acid into the cytoplasm. Now in the cytoplasm, as the malic acid concentration increases, because of the efflux, it will inhibit PEP carboxylase. If PEP carboxylase is increased, there is no more fixation of carbon dioxide happening. When will that happen? During daytime. You see how by daytime and night time, how by playing with this particular enzyme and altering the concentration of making malic acid available and not available, how the short-term regulation is being carried out. Very interesting story. How is the long-term regulation of CAM pathway occurs? We know that the CAM plants are generally seen in arid environment. Now the long-term regulation is generally for months to years. A plant will decide not to open the stomata for months to years, so that there is no exchange of gases happen, and it will circulate whatever is the available carbon present inside. It will circulate, and that is how the plant will survive. When the rain comes, the stomatas will open and it will switch over to C3 pathway. That is the time the plant will grow. So one interesting observation is that CAM plants generally, they do not develop so much of biomass. They don't grow so big. That is an observation about the CAM plants. This is the reason why they do not grow so big in comparison to the C3 plants. When we are discussing about CAM pathway, we need to talk a little bit about the isotopic studies that have been carried out. So we know that the atmosphere contains the two isotopic forms of carbon. The two isotopic forms are, one is carbon 13, that is about 1.108%. Carbon 12, which is the most abundant one, that is 98.892% is the available in the atmosphere. There are two crucial enzymes as well in fixation of carbon. So, in one of the enzyme is rubisco. And the second enzyme we have encountered, that is phosphoenol pyruvate carboxylase. These are the two enzymes that are used for fixing carbon dioxide. What is interesting is this rubisco has a preference for C12, which means if the C13 isotopes is least likely to be in the carbon dioxide that is fixed by rubisco, whereas PEP carboxylase has no preference. Depending on the availability, it will fix carbon dioxide. So therefore, what is the ratio of the carbon dioxide based on these isotopes fixed? That ratio is denoted by this particular expression, that is the delta of the C13 percentage, which can be calculated in this manner. If the ratio of C13 to C12 in the fixed carbon of a plant divided by that particular ratio in the standard. Generally, the standard that is used is calcium carbonate. Is used as a standard, -1 into 10 raised to the power 3. Whatever is the value, based on the value, we will be able to say which pathway has been active, whether it is a C3 pathway is active or PEP carboxylase is used by C4 and CAM pathways. Which has been active, we will be able to draw conclusions. If the ratio is 0, that means there has not been any preference towards C13 or C12 carbon atoms. If the ratio is negative, which means there has been a preference for 312 carbon atoms. Now, generally for a C3 plant, if the ratio is between -23 to -24%. For a C4 plant way, this ratio decreases to -10 to -18%. When it comes to a CAM plant, this ratio is between -14 to -33%. This is because if the CAM plants will shift to a C3 pathway depending on the environment, availability of water and the temperature. What are we learning in this particular video? We looked at the CAM pathway, how certain plants have been modified or evolved in order to adapt or survive in arid conditions where there is a scarcity of water. What kind of metabolic adaptations and morphological adaptations it has. And we have also looked at the kind of study, isotopic studies that has been carried out in order to understand the fixation of carbon in CAM plants.